Hello and welcome to yet another episode of the Trino Community Broadcast. Today we're going to look for patterns. My name is Matt
Woohoo!
Bosa, and as usual, we'll talk about Trino, everything in the Trino community, big data, data mesh, SQL, and you'll see today there'll be a lot of SQL. Your brain will be smoking. It's going to be super interesting. Kasia is going to be an expert joining us. So welcome to today's episode. Brian host is as usual hosting with me again. Brian.
Hey, everybody.
And today we have Kasia joining us all the way from the other end of the globe, back in good old Europe.
Hello, everyone. Yeah, I'm Kasia. I live in Warsaw. I'm a Trino maintainer, and I'm really excited to be here.
We're excited to have you,
Kasia. Joining
Kasia.
us. That's going to be super awesome. But before we get to learn a lot more about Kasia and her incredible work she's been doing on Trino for many years now, we'll talk about a whole bunch of other things. So what's been happening, Brian?
Oh, not too much. I'm literally finally getting back to my professional mic. I don't know if anybody noticed in the last couple episodes, but my microphone has been really like choppy, and it's because I did not have my studio. I still don't have my home studio. I'm getting kind of used to this whole trying to do this in a public setting. So I finally have my wonderful smooth mic back. Just hopefully getting into my own studio at home at one of these days. But we're getting there.
It's weird how you love to end up having some equipment with you to do certain things, right? Like a proper green screen. It's like, who the hell would have thought that a green screen is something important at some stage? But,
totally. Yeah, definitely. But other than that, we have a Trino Summit coming up. We'll talk a little bit more about that down the line. And yeah, I think I'm really excited to hear about Release 360. Before we hop into all of that, though, and get into all the fun pattern matching stuff, let's hear a quick word from our sponsor, Starburst.
I'm Colleen Tarto. I am the Director of Engineering on Starburst Galaxy.
What is it actually offering? So, I mean, I think this kind of like builds on some of the open source Trino stuff, but is it doing a lot more? What kind of pains is it solving? Could you kind of give us a little bit of insight on what actual pain this is going to be alleviating?
Yeah, absolutely. And so to think about that, I always like to go back and think about what's the difference between Starburst Enterprise and Trino, right? And so I always like to think of Starburst Enterprise as the cool older sibling to Trino. It's a little bit more mature, a little cooler. It's got a car. It's got some cool stuff going on, leather jacket, And Trino is awesome in its own right, don't get me wrong, but Starburst Enterprise is just better and a bit more grown up. And specifically what that means to me is that with Enterprise, you get more functionality, faster performance, more connectors, more security, better management, better integration into the ecosystem of tools that you already use today, data governance, integration, et cetera, et cetera. But what really speaks volumes to me is that when you use Starburst Enterprise, you get Starburst, right? You get best-in-class support from the folks who work for us, and they know Trino best because they created Trino, and they're continuing to contribute to Trino. But Starburst Galaxy takes that to a whole nother level, right? So one of the pain points is installing, managing, maintaining, monitoring Starburst Enterprise. And so Starburst Galaxy alleviates all of that, right? So it's a fully managed service. It's Starburst Enterprise as a managed service and more.
And one last question, is there going to be any free offerings coming up anytime soon? Is that on the road?
Absolutely. We're building out, we've got a free trial. So if you're interested, absolutely reach out to us. We are very excited about it. And then we're talking about sort of a free tier. So like being able to just play around with it in your own environment and see what's what.
We'll keep you all up to date on when you can start to play around with Galaxy and Trino for free for just a little bit and get to know this incredible service called Starburst Galaxy. Thank you so much, Colleen.
Thank you.
All right. Oh, where did we stop in here? We missed out on, there we go. There's everybody. Manfred, you told us a little bit about Release 360 in the previous episode, a little bit of sneak peeks, but tell us about all the cool stuff that's come out since then.
Yeah, we come full circle, right? 360 releases out, and it's ready by the end of the month. So just a couple of days ago now, basically, the official announcement from Martin contains a lot of the things that I sort of like spilled the beans on already last time. So we do have the automatic configuration of TLS for cluster internal communication. So that used to be super painful. Now it all happens automatically. That's relying on some of the amazing hackery from Dane and David, working with the Jetty developers. So essentially, what happens is you don't need to create any certificates for the domain names of the individual workers. It all happens automatically based on the IP address. All you have to do is switch on one configuration, and I got that documented as well. So check that out. Super awesome if you need this sort of like super end-to-end secure communication, which includes inside the cluster. Martin also mentioned the improved correlated subqueries with group by or limit clauses. That's improved. The Elasticsearch connector, your favorite little connector, Brian, got AWS Identity Asset Management as a role, so you can use that for authentication, specifically useful for people that use the Elasticsearch connector in an Amazon use case. So
that's a pretty big one too, because I know there's a big shift, when Elasticsearch changed their licensing and stuff, a lot of people went to open distro. Yeah. So that's, also, I think where this is also applicable. Yeah. Open distro is pretty much equivalent to at least how we use the API and stuff like that is equivalent to. Yep. So you can use that in AWS if you have like all the security stuff set up there. Now, if you're on Open Distro, you can take advantage of that. So that's big.
Yeah, it's also super nice to have that in other connectors over time. Maybe specifically if you run on Amazon RDS, right? You run your PostgreSQL database there, which you can connect to as well. Over time, we maybe be able to do that as well. So that's cool. Iceberg. There's always stuff happening in the Iceberg world, as we know. This time, remember when we talked about views with Anjali, she's like, well, Trino doesn't support the normal views in the Iceberg connector, only the materialized views. Well, voila, that is no longer true. So the Trino Iceberg connector now supports normal views and materialized views. So where maybe performance is not as important and you don't have enough storage to have a materialized view, you can still now use a view itself, which is super awesome because it can abstract a lot of the complexities and pains of like queries away into a dedicated view that your business analysts can do. So
so to be clear about we on episode 18 we jumped into this, and if you look at this chart here, we were saying that we only allow Trino logical views on the Hive connector, and then we said it's not available on Iceberg connector. After 360 now, this changes to a check mark here. So if you go back and you want to learn all of there is to know about views, definitely check out episode 18 and just know that this Iceberg now supports logical views on the Trino side. So really cool, really excited there. And again, thanks to the Netflix folks. I believe it was the Netflix folks that did that one as well.
No, it was the Starburst folks, but.
Oh, okay. Oh, well, thank you, Starburst.
Sure we work very closely with the guys from Netflix. We're all working together. This is all one big community where we get a lot of stuff done together. In fact, I put my little bit of effort in as well, because what I did is I documented the materialized views for the single commands and in the Iceberg connector with the help of Anjali and others. So
we had a lot of people asking about, in general, we're just getting as many questions coming in about Iceberg. So anybody who wants to do like any code any documentation to kind of get nudge their way into the community, please, like Iceberg, there's so much low-hanging fruit to do on the Iceberg connector. Like that'd be an incredible help for a lot of people out there. So definitely if you want to get involved, that's an easy way to do it.
Yeah, and we have the good first issue tag in GitHub for issues as well, so you can always poke around there.
Definitely.
Partial support for delete and batch insert was added to a whole bunch of JDBC-based connectors, which is pretty cool. So
nice.
That's a bit of a performance enhancements for the inserting of data. Obviously not a common use case or the core use case of Trino, but still useful to expand more and more. In general, if you look at the top of the release notes directly, we're not worth looking now, but there's a whole bunch of fixes for like performance and little correctness fixes. So it felt like there's more than usual. There's always a whole bunch, but this time it felt like there's even more. And then there's a numerous improvements also on the Iceberg connector beyond just the adding of the
I know.
so,
It's too easy to say that word sometimes.
Yeah. I just saw another video before where it's like talking about don't always say very. So
yeah. Yep.
Not just very good release.
Yeah,
anyway,
we don't want to
so
minimize
that was
it.
the 360 release. Awesome to have it out there. Try it out. Should be very good.
Awesome. Well, great. Other than that, let me pull up. We have and I should have brought this up beforehand. Silly me, I always do things right as I'm thinking about them. So we had this blog that just came out announcing Trino Summit. And we basically letting everybody know we are going to be hosting a hybrid event. So it's going to mean that we're going to have some speakers that are going to be there in person. Also have a small amount of people if you want to sign up today. So definitely if you want to go to register, you go to the register page, you can click on either live or virtual. And if you're going to be there trying to attend live, we can't guarantee the amount of seats. It's very limited. And we actually have it at half capacity to start with, just due to trying to safety precautions for COVID. But then, if you're not able to do that or you're not ready to travel, well, of course, please join us virtually. The date needs to get updated on this blog. I will be updating it to October 21st. We had a conflict with the vendor, so we will be moving that again one more time. Really do apologize about that if you have already booked for October 13th. So it'll be now on October 21st, and we'll be announcing that, re-announcing this and basically refreshing this blog. But look forward to that. We have Netflix is going to be joining us talking about some caching stuff is kind of in the works. We have some hush hush stuff that we can't talk about yet from LinkedIn. We also have the Robinhood will be joining us. They're still figuring out the exact specifics around their talk, but definitely going to be talking a little bit about their infrastructure. So a lot of really cool people that are out there using Trino. Really excited to have them speaking at the event, and a lot more to come from there. Of course, we're going to have Martine, Dane, and David. They'll be giving us all of the updates on all the cool things that have been happening throughout the last year. So look forward to that, and I guess that's pretty much it for that. You anything else news-wise?
Do me a favor, go to the homepage for a second.
Oh, sure.
So I just want to mention this. Check out all the logos there. Like, we got some more added again. I noticed that Shopify is now also a real well-known entity that's using Trino. So we have a lot of people that are using Trino that are well known in the industry. So it's got to be something there. It's a pretty damn good thing. You should try it out.
Yeah, for sure. Yeah, thanks for recent additions here as Cloud Chef Labs, Data Sapiens, and Didi. Thank you all for joining up and giving us your testimonials. Anybody who's on this list that has agreed at least to do this, if you want, please leave a testimonial if you haven't already. And if you are not on this list and you want to be on this list, reach out to Manfred or myself on the Slack channel or on Twitter. Our handles are on our little name tags over here in the stream. So yeah, please do reach out to us, and we'd like to definitely get more people who are using Trino, letting everybody know your story and what you have going on. So great. So with that, let's go. Are you ready to go on the concept of the week, Manfred?
We have a concept of the week. Sure, go
to the concept of the week. We got to get that smoother at some point. We got to figure out how to I want it to be very epic build up to that, but I feel like I always stumble right before I get to it, but we'll work on them. I swear maybe in the next maybe 5 episodes.
Trial and error, Brian.
Okay, well now we're here to your portion, Kasia. Thank you so much for joining us. And I think before we just directly jump into the technical stuff, I really want to kind of do more. We've had some other technical folks that are from our Trino project, but that's mainly been Martine, Dane, and David, Manfred, and myself. So otherwise the guests have been outside. So I really want to kind of let people get to know about the maintainers and the contributors a little bit better. And you in particular are a maintainer. Could you just tell us like a little bit about yourself, maybe where you're from, hobbies, things like that, just to let everybody get to know you?
Sure. I live in Warsaw, Poland.
Okay.
I am indeed a Trino maintainer, but much more I consider myself a contributor.
Yeah.
Yeah, I've only become the maintainer recently.
Yeah.
And in a private life, I'm a mother of a big family. I say big family.
Nice.
And Trino is my hobby.
Yeah.
It has not become a job, but it still feels it's just so gratifying, and it feels so good to do that. It just fuels me like a hobby should. So
yeah,
I think of Trino as the hobby.
That's a great hobby, right? we like it.
Yeah, that's good.
So
that's awesome to juggle parenthood and that stuff is cool. I have 3 boys, so it's always, it's never boring. It's definitely fun. So that's cool. Yeah. So obviously you've been developing quite a bit. So I got started with a Commodore 64, hacking around on an assembler a long time ago. How did you get into software development?
Oh, that's not a long story. I think it's quite a short story. Well, I used to study computer science long ago, but I actually never finished that. Then for many years, I was busy doing other things, basically the family stuff. And then eventually, I just took up programming as a hobby. And for that, I started with Project Euler, which is kind of algorithmic competition.
Yeah.
And that required me actually to learn the very basics of Java to be able to code anything, because I basically wasn't able to. And the rest was just about logical thinking. So it didn't require any knowledge, actually.
Yeah.
And the next thing was that I met Trino, thanks to my husband. Actually, it was called Presto at the time. And I began with some small contributions, and then gradually I did more and more complicated stuff.
Awesome.
That's it.
Well, and I'd like to go a little more, what's your role in the Trino project? Like, what kind of work do you focus on? What things get you excited about Trino?
I've been involved since 2019, and my area is not a very broad one, I think. I mostly work on adding new language features, like the match recognized recently, or the with recursive syntax, or window clause, just to name a few. And other than that, I work on optimizing the query plans and on supporting different kinds of correlated queries.
Yeah,
I like how you say that casually, when literally this is like the super core of the system and the most complex parts.
Yeah,
you're like throwing it out there, just like window clause and match recognize. And I'm like trying to help you read the documentation, like write the documentation, and my head is just smoking, and I can't even think about
I know
how you like write the code. So I love how you say that so casually. That's super amazing.
So if anybody doesn't know, Kasia's super humble, and she's not going to tell you how incredible and all the cool things she's done here, but we're going to brag for her just a little bit and say she's incredible. So, great work on everything that's come down the line. Even in the last, I think it's really been like a lot coming down in the last 5 releases. Like, when did we get? Actually, window function's been here for some time. Like, it's been. Do you remember what version was window function, Manfred?
I don't remember, but it's been like constantly getting improvements from customers.
Yeah, it's huge. Did the correlated subqueries is also another one of those things that you spend some time in as well, right?
Yeah. For example, I added support for correlated subqueries involving unnest.
Yeah.
Other shapes, they usually every shape of those queries requires special handling. So,
So So
one thing I wanted to say, just was mentioned by Ashar, was he said like language features and optimizers, and really it's like the most challenging part and lies at the core of everything we do. So I think he just pretty much echoed what me and Manfred were saying. Like it's not easy stuff. If for those
just for those that don't know, Ash is one of the other another prolific maintainer. So he knows the code base, so he knows what he's talking about.
Exactly.
A bit more than you and me, right, Brian?
Yeah, no, we dawdle around on documentation and some of the connector stuff, but this is like the real meat of the core engine. So
a question, Kasia. When you say you're writing like the SQL standard and implementing things like match recognize, one thing that I always find super annoying when I look into SQL is like how the different databases have these different standards and they all have their own documentation. And then Trino obviously tries to stick with the standard, right? But then when you want to read the standard, there is no standard documented. You have to buy like things from ANSI and whatever. Like how do you know what the standard says? Like now and then I see like Martin saying, well, the standards is this. That's what it says. Like it's literally like, how do you deal with that?
You just have to read it. I know that often there's no use checking what other databases do, because if there's anything that's doubtful, that you don't really know intuitively how it should behave, then there's also no use checking other databases because they all have it different. Mm-hmm. So the thing you really need to do is to go through the standard. And we are very focused on keeping to the standard. And I can say that it's terribly hard to read, terribly hard to understand, and it takes a lot of effort. But I believe that I believe that there are really smart people behind it, and if something is there in the standard, then they put it there for a reason. So it's just worth following. That's what we do. We don't reinvent the features. We don't do some variants of the features, but we just try to have them as they are described in the SQL specification.
Well, and with that, you get some alignment. It's just great that you have like standards in general, whether or not they're perfect. It's better that there's a standard than an imperfect standard, or an imperfect standard than no standard is what I would say.
Sure.
So do you actually have access to the standards? Like you have some sort of subscription where you have access to the real like there's like NCC, I don't know what the latest one is, like 2017 is that the latest one, or 16 or so?
2016 is the latest one and the fattest one. Actually, it's nothing like the previous standards. Every feature goes in hundreds of pages. So it's a challenge. Yeah, it's a challenge in itself to read it.
That's awesome. One day we'll have to play around with. You have to show me one day when I'm come over to Poland. Hopefully in the next couple of years.
Yeah, I'd love to just see the scroll that you have and roll out the giant book. One last question I had, Kasia, before we move on to actually diving into Match Recognize, was how did you make these really cool SVG? These are awesome.
The pictures. I thought that would be some very difficult part of writing a blog post, because I've seen a lot of those great pictures around, and then I just found that Google Drive has got an excellent tool. It's called just Drawing.
Okay.
Drawing, and it's so convenient. It helps align the objects. It helps to copy them so that I can reuse my work, and it's just right for this purpose.
Wow.
It's great.
We're advertising Google now on this. Google Draw, everyone. Well, great. One last comment I wanted to bring up. This is from Rose. She said, "Yay, Kasia!" So we have Kasia fans in the stands right now. So thanks for that, Rose. So let's go really hop into this. I want to, before we totally jump into a lot of the kind of technical aspects of like, all of this stuff. Why would we actually want to have something like Match Recognize? I think, if you look at this query, it's a little like, it looks a little scary to begin with. And so you clearly have to have some understanding for this and know how to do this. So could you kind of walk us through, if you want me to, I could bring up the blog, or you tell me what you want me to bring up, but just walk us through kind of why somebody needs match recognize versus just using kind of simpler SQL stuff.
Okay, I can try to.
Sure.
Simply said, match recognize allows you to use regular expressions to find patterns in your data, right?
Okay.
And if the match is found, if your data matches the pattern, then it also allows you to take any metrics you want from that matching data. It even supports special syntax to do it. And the cool thing, the thing that I really like about Match Recognize is that it's not just another tool that you can put on top of Trino to consume the output of Trino, but instead, this is a part of pure SQL. So you can use it directly in your query.
Yeah.
You can even use it multiple times in your query. Yeah. And you can, for example, put one match recognize on top of another inside your query if you want to check if your patterns follow some other patterns. I think that's really cool.
Yeah.
So if I understand this correctly, it allows you to do things that like pattern recognition and like processing data for patterns that are otherwise require multiple SQL statements and maybe some post-processing and all this other complexity. And with Match Recognize, you don't have to necessarily do that anymore. I'm
not sure if you can get that much power from SQL not using Match Recognize. Combining many statements. That's probably, Match Recognize is probably something more powerful than anything else combined.
Wow.
So you would have to like actually write something else, like get the data with SQL and then post-process it with Python or some other.
Probably, yes, probably so. Yeah.
Okay. Yeah, so that's super painful, obviously. So yeah. So let's tell us more about this Match Recognize. You got me interested here now. What's going on?
All right. Well, I could think of some real life example. I'm not a data analyst. I think that a data analyst could come right away with some interesting examples of some use cases for that. Well, if, for example, if you are a person responsible for security in some financial system, such person certainly knows what are the symptoms of something going wrong, right? They have to just detect it. Maybe some usage patterns that signal a fraud attempt or some other danger. And if that person is able to encode this knowledge in the form of a regular expression, then Trino can find those events for them, right? Or I think that
I can think of another one. So you tell me if that might work. Remember, Brian, a while ago we had someone as a guest, I forgot now, but they were basically doing like security detecting of logs and analyzing for like attack patterns and stuff like that.
Was this Resurface you're talking about? I think so. Yeah, Resurface was doing this.
So they're using Trino with the memory connector, and they basically get all these like attack logs and like on web servers and stuff like that.
Yep.
And he was literally saying they check for patterns. So it might
well be possible
that they can use that.
Yeah, that's the perfect use case if they run it on their logs and define some pattern which is interesting.
And again, they probably would have had, I'm guessing in their solution too, they're probably having to run either some sort of custom thing, or they have like maybe a function that they wrote that plugs in that makes this magic happen, because they had to customize a couple of things about Trino, and that was one of the things that they loved about it was, oh, you can customize these things and it's great. But
so now they have Match Recognize.
Exactly. So now this is built in. They don't use it. Yeah, they wouldn't use it yet, but maybe that's like, now they wouldn't have to do all this like custom stuff. They can just use the upstream, like, open source project out of the box without having to, do some crazy thing. And all of it's done in SQL. That's I think the true magic that we're trying to achieve here. So
Rob Dickinson, if you're watching, talk to Kasia. Let's find out more.
Yeah, that'd be really cool if we could actually combine these use cases for sure. So, the challenges, was there like, to get something like this with this heavy amount of like functionality to work, like there has to be a lot of challenges that you face to get this like set up in Trino. So could you kind of run through like what changes on the SPI, or was there anything like, yeah, obviously we had to add the grammar for match recognize unless we had it before. So like what changes needed to be made to actually make this work?
Oh dear, that was a lot of changes. That was one big challenge. Yeah, and the challenge didn't even begin with implementing the feature, but first I just had to just read through the specification, which is way more than 100 pages regarding this feature. And
Wow.
I just had to read deep into that, and you know how terrible it looks.
Yeah.
The spec and it's weird grammar.
Yeah.
So I read into it until my brain developed some new part which could think like match recognize. Only then there was the time to start implementing the feature.
Oh wow.
And then it required changes just all along the path of the query processing, from introducing the grammar to handle this syntax, then the analyzer part to analyze this kind of queries, then the planner part to plan this query, and for that I had to introduce a new plan node to capture this functionality.
Okay.
Then the optimizer part, because of course we added a bunch of optimizations. Finally, the execution. Well, one of the challenges was that there is a new abstraction that had to be added to Trino to capture the idea of the pattern label, just the pattern component. The pattern consists of some components, and Trino never had anything like this because it wasn't needed before, and it is crucial to handle this kind of query from the grammar up until the execution. So it had to be introduced.
And this patterns, does it apply anywhere else, or is it only for match recognize?
Actually, according to the spec, you can find those patterns via the match recognize clause, but also in window. And
okay.
The other kind, the window extension, is something that we also added recently. So we now
cool.
have both kinds of pattern matching.
And I think you documented that. We'll cover that here. I think that's going to be the pull request of the week. So we'll get in a little more into that, the window one here in a little bit. But yeah, it was just while we were in this train of process, I wanted to make sure we covered, does this pattern, is this only a match recognizing, or is it more broadly applicable? And it looks like the answer is yes. So
yeah,
cool.
There are two ways of using this,
cool.
2 ways of matching patterns, and they differ a little both in syntax and semantics.
Very cool.
And the biggest challenge actually of implementing this feature was in the execution.
Yeah.
And I like to explain you why, but it's quite hard to explain because normally operators work in the way that they get an input stream of data. On that, they do their job and they pass on the stream of data. And it appeared that this model was too limited to handle the case of match recognize, because it not only uses the input stream of data, which it does obviously, but it also computes on the run and uses much more data. And some expressions can be evaluated only when you combine the input data with the other data you've got.
Okay.
So,
that's because, so just to understand, right? Because I think that's because match recognize works on a number of records, right?
Yes, it works on a number of records. And additionally, so it's like a window function when you have a frame.
Yep.
So that's a good analogy. But additionally, you also have the match, which is in progress. So the labels matched to rows and the other properties of this match that can also participate in evaluating expressions inside the operator. Actually, I'd like to show you a picture.
Sure.
Brian, could you please show that picture? No, the one below. Yeah, this one. This long, colorful string at the top.
The red?
If pref start price 1, the long just below the word measures.
Just below the word. Oh yeah, right here. Okay.
This is a long expression that you can write inside the match recognize clause.
Mm-hmm.
It contains a lot of the special syntax. I mentioned before that special syntax is supported, and this special syntax makes those expressions very powerful, very expressive.
Yeah.
But it also was a great challenge to implement.
Yeah, and if somebody's curious about this that hasn't seen Match Recognize before, a lot of this is actually covered in this blog, and we've linked that from the show notes. So Kasia covers this beautifully in this blog. I think it's somewhere down here. So if you want to learn about all of the specific syntax of like measures and prev and all these other pieces, that's all included in this blog here. So we're going to gloss over it a little bit as Kasia explains it, but just know that if you want to dig into this, it's there for you. So continue, Kasia. I just wanted to mention.
So that's this long, colorful expression. Sure. And it has a lot of this special syntax restricted to match recognize. It says prev, it says match number, last, classifier. These are all keywords that you can use in match recognize. Mm-hmm. And to evaluate this expression, which you probably need to do for every row, you have to. Can you please scroll down to that picture?
Down to the picture again. Sorry.
Yeah, this picture, because I wanted to show where are the values that you need to combine. Like this, in the red frame, there is some input value from the input channel. And in the blue frame, there is another value from, it's the same column, but different row. Mm-hmm. And this you have in the input, but additionally, to evaluate this expression, you need the match number. This is the purple frame with 1 in it.
Yep.
This is something that is only known to the operator, and it is only known at runtime. Yep. And another thing is this up in green frame. This is a pattern label. This is a component of the match, which is also known only to the operator at this very point of matching the pattern. Yeah. So only if you get those 4 values and you combine them, then finally you can evaluate this expression. And maybe that doesn't look so, I don't know, amazing, but to me as a developer, that was the biggest challenge of implementing match recognize.
Well, no, and we'll see a more specific example in the question of the week on how you could apply something like this. And also there's another good example that Kasia is going to go through in the demo of the week that will go over TPCH data. It's a little more abstract, but it's also like something that you can just run yourself. So a lot of this, and when you first look at it, may seem like not make sense, but when you come back to it and you run it yourself and you kind of see what's going on here, you'll actually you'll reach this aha moment. Okay, this is how it works, and this is what it's doing, and then you can kind of extrapolate all the different things that you can do that in SQL to actually do something even close to this. You just, like we were saying before, you really just can't. You would pretty much have to take this out of some imperative language or some sort of or dynamic language or Python or something like that, and do the actual coding there rather than just being able to get it out of bare SQL. So this is it's hard to explain, and you've done an incredible job at actually explaining it here, but to be able to actually go through, label each row in a particular type of pattern that you're looking for, and then apply some sort of either statistical analysis on that's actually a very heavy tool, and it can be applied to many different operations or many different data processing that people aim to do in other ways. And so you can do it once you can think in the terms of match recognize, it becomes very clear on how to apply different problems to this space. So very, very cool. And I think this is, that's my take on it, but you explained it super well in the blog there, Kasia.
Maybe we should check it out in practice. I think, like as usual, when you see these things in action, it gets much more interesting.
It's also true. Yeah. Well, before we hop to that, do you want to actually go over? Well, or do we want to go straight to the demo, or do we want to hop over the PR? What do you think?
Okay. maybe we could go through the syntax.
Yeah, let's go ahead and do
That's
that.
part of the PR in a way, because that's where we document it. So I guess that one works well together.
Yeah. So let's see. So were you saying you wanted to cover the syntax
cover
here?
it there. And
Yeah.
the PR of the week basically was where we wrote the documentation for match recognized. There's another one where we wrote the row matching in Windows window clauses. The result is essentially documenting what Brian is showing here, which is the syntax or an example query. So Kasia, you want to give us a bit of an overview?
Sure. Yeah, please.
All right. So this is this one example of a query that was run in Trino. It used some sample data, and this data is declared here at the top. It is the table.
Oopsie, that was my bad.
It's the table orders. It has only 3 columns. There are customer ID, the order date, and price. And if you take a look at the column customer ID, it has only 2 distinct values. So there's just customer 1 and customer 2 in it. All right, and now the match recognize syntax. It begins with this keyword match underscore recognize. And all the rest of the query up until the query end, this is actually the inside of this clause. So it has got many subclauses, many options inside. It's a big portion of syntax.
Totally.
And I think that I'd like you first to take a look at the pattern clause, because we are searching for the pattern here. So that's the first question. Where's the pattern? So it's here near the bottom. Yeah, it should be at the top, I guess. But for some reason, the pattern clause is here at the bottom, and it says start down plus, up plus. And as you remember, that's just a regular expression. So we can read it as one row is matched to start, then one or more rows are matched as down, and then one or more rows are matched as up. Yeah, but how does the engine know which rows can actually be matched as start or down or up? Mm-hmm. And this is what we do in the define clause. That's the clause at the bottom. It says define down as price lower than previous price. So now we know, and the engine knows, that the row is a down row if the price is descending compared to the previous row. And it says define up as price greater than previous price. So up is about ascending rows. And if we take a look at the pattern again, then we see that first we have a sequence of descending prices and then sequence of ascending prices, which together form a V shape. That's why we call it a V pattern.
So here we have the top row. I'm gonna be the dumb algorithm right here. They have the top row, and then I say, okay, I'm analyzing this price, and I'm trying to compare previous prices. So if I'm comparing previous prices in this partition of customer 1, I look here and I say, okay, let's start with this price. And I'm going to now see if this goes up or down. So in this case, I go from 200 to 100. So I'm going to label this row as down. Go to the next row, 100 to 50, down. And then I go 50 to 100, and then that goes up. So that is how we are labeling. And that's how the labeling is basically getting defined here.
Yeah, exactly.
Perfect.
All right. So when we have the pattern and define, the next important clause is the measures clause. That's because here you specify what actual information you want about the match that is found. If you found the matching portion of data, then what do you want to know about it? And here it says start price. So the price is at the first matching row. Then the last down price, that will be the last price at the descending slope. So that will be the bottom price effectively. Then the last up price, which is the last price on the ascending slope. So the final price. And we also ask for the starting date and the final date. And that's all the information we want.
Perfect.
So those are automatically also the fields that are returned here. In this case, on your select statement, you are returning the customer, and then those other fields because that's what you're interested in, right?
Yeah, you declare those fields, those measures in match recognize, and you can simply select them from here.
Cool. Very cool.
All right, so let's see what else can we do in match recognize clause. From the top, we can partition the data, and that's very reasonable, because if we have information about all customers in our table, but we want to analyze it per customer, then it's reasonable to partition it by customer ID, so that every customer forms a separate partition to be processed distinctly from all the others.
So how, so this is the tangent now, but I'm assuming that then means that those partitions are somehow created in the execution and are actually distributed across the cluster and processed in different workers and shares potentially. Is that right?
Yeah, you can. That's an analogy to how window is processed. You can do partition by if you do window functions also. And actually, match recognize uses the very same mechanisms for partitioning and for ordering as window.
Cool.
So
very cool.
It doesn't make any assumptions on the data. It doesn't require the data to be pre-partitioned or anything like this. It just can take care of it.
Okay.
Cool.
All right, so the next thing you can do is order by. Here it orders by the date. That's because you just want to match the pattern on a sequence of data over time.
Yeah.
And the fact is that this order by clause is not mandatory in match recognize, but I strongly advise that you always do order your data, or otherwise, if the data arrives unordered, you're matching your pattern to some random sequence, which is not very useful.
Yep.
Right.
And also,
right.
like in a practical perspective, like say your example here, for example, if you wanted to detect customers that over time spend more and more money, or the ones that don't, and then find out why, there's always an order that makes sense from your, like just from the pure analytics perspective, right?
Yeah.
So.
Yeah, of course.
Almost always it's a temporal or time series type of measurement that you're trying to do.
It's usually ordering by the time, but there's no requirement of this kind, of course. You can order by anything you want.
Yep.
All right, so we've got two more subclauses here. One is one row per match, which just says, for every match, give me a one row summary of the match on the output. Okay. Alternatively, I could say all rows per match. And in that case, the output would be much more extensive. And the last clause says, after match, skip past last row. I think that's quite self-explanatory. It just says that if you have found the match, you want to start searching for another match right away. So you skip this matched portion, and from there you start your search again.
So if this were to be, let's say we found a match, I don't know, like let's say this second row is a match, and ignore like kind of like these existing labels and stuff. So if we found a match at row 2, we would start at row 3 then? Or
no, it says skip past, right? So you match.
Yeah, if the previous match stopped at, if say the row 200 is the last matching row, then you start with the row 100.
Okay.
The next match you can start at the row 100.
Because if you don't do that, then you're going to actually match on the last row of the previous match, or including the matching row, I should say.
No, with this option, the last matching row is not included. But you have many more options available, and actually you can skip to the last matching row.
Okay.
But I think that the most useful option, other than skip past last row, is after match skip to next row, which means that you, no matter how big the match was, you only take one small step forward, because that allows you to find an overlapping match if it's there inside the previously found match. So
there's
this smallest step you can take. So this lets you find all the actual matches, including overlaps. And skip past last row just doesn't give you any overlaps.
So if you go down to the picture for a sec, Brian, I think if I understand this correctly, is like the skip past last row means in this case we would have detected from 200, we have detected the V-shape 150, 100. So the next match would skip past this whole display table and go with whatever, like 400 or whatever the hell is next, right? Yeah, that's cool. So basically, once you detected the V-shape somewhere, you don't try to analyze that data where you found the V-shape again. You skip past it and look if in some other future data.
Correct.
Yeah, cool. That makes sense, Kasia. Awesome.
There's this one thing that just made me think of just now when it comes to time series analysis, and this is totally tangential. So nothing I'm going to ask you or anything right now, but this is just something I wanted to think. This would be an interesting thing that we could see if we could at some point apply to match recognize. There's this. These algorithms that do trend analysis and anomaly detection, where you can look at this initial signal and then you look for like seasonal patterns first. And then basically based on the seasonal patterns that repeat over and over again, you clear that, you subtract that from the original signal, and then you get a trend pattern. And then from that, you can take that out and or subtract that from the original data as well. And then you get what's called a remainder. And these kind of indicate anomalies. So this would actually be like multiple process of match recognize, but would be interesting if you could actually do something to this level in just pure SQL. I don't know how performant it would be, but it would definitely be cool to see if you could do something like this. So maybe we'll bring that on a later show one of these days. So anyways, just total tangent. Just this got me thinking in terms of
but
time.
Yeah, you're right.
Data.
Signal processing is definitely one of those other ones where you can do that sort of analysis.
Yeah, totally. Okay, so back to the real show. So we covered at least these syntax. Was there? Let me see if there was.
That's. I'm telling you right now that it's not full syntax.
Okay.
It doesn't have all the subclauses, but that would just take too long, I think.
Yeah.
So, and for those interested, the documentation that Kasia wrote and we edited together contains all of the complete syntax.
Yeah.
And there's a lot of things. There's good examples and everything there. And ultimately, I think you just have to play with it because it is darn complex.
Yep.
But also super powerful. And as usual with these things, when something gets complicated, you just need to get your hands dirty.
Totally. Well, do we want to move on to the PR of the week? Let's do it. All right. So hold on, let me move back to this one. So this week's PR of the week is also done by yours truly, Kasia. So I used yours truly wrong. I was actually meant to say Kasia because yours truly would mean I did it. This was something we wanted to bring up because we typically have done a lot of code pull requests, and we haven't been showing much love to like documentation. And so this is just something that I think in general across the board, we want to make a much more like a clear thing that how much documentation helps the project, especially when it comes to these complex pieces that, we're discussing today with Match Recognize. This one in particular is covering the other thing that we do pattern analysis with, and this is done on the window function. Kasia, could you tell us a little bit about kind of what this feature is in contrast to like Match Recognize?
Yeah, this is not like an outstanding clause, but this is this pattern matching in window you can achieve by just adding a few more subclauses to the window clause. And actually, this is something that happens in the window frame. So
okay.
That's conceptually difficult, I think, because first you define the frame, the window of data on which the window function works, and then inside this frame you search for the pattern, and when the pattern is found, then the frame is further reduced to the area of the pattern.
Got it.
Oh, okay.
but also it can define the pattern measures. And in this case, the pattern measures are not selected like we did from match recognize. We did select this measure and that measure and that measure.
Yeah.
Here, you don't select the measures, but you call them over the window in the manner that you do window functions.
Got it. Oh,
So,
wow.
yeah, so you can select some measure over the window, which actually defines this measure inside.
Great. So this is actually good. Like, I mean, this is two different places you're using a lot of the similar syntax. So somebody who's like actually coming in wanting to use this type of functionality, you can use it in or learn it in one place and kind of apply it at the other. But the difference here is that you instead of actually getting like a row set or something returned that you can play with in the match recognize type clause, you're actually, this is just going across the context of a particular window frame.
Yeah, so there's like everything that happens over window, you get one output row per each input row.
Yep.
There's no way of outputting all rows per match here.
Okay, got it. Okay, that makes sense.
And in this case, maybe it's worth showing. So go to the website itself. This is all the documentation written in our usual restructured text. And then if you go, and this is now added in the
SQL language?
SQL
statement syntax. Okay.
You see there is there's the new create materialized views, but if you scroll down a little bit, there is the match recognize, a dedicated page, and then the row pattern recognition in window structure, also a dedicated page, because there's just too much to learn. So we didn't want to fold it into, it's a subsection of the select, obviously, but the select page is already super long, and this is a really complex additional topic. So we're breaking it up more and more to have separate sections where you can literally concentrate on the one feature you want to explain. And this is the result on what it looks like. So it's really nice.
Great.
Very good.
Yeah. So if anybody wants to learn about this stuff, dive into the documentation and let us know if there's anything missing or anything that you'd like to document or have documented yourself. And maybe you could even add your own pull request. So thank you so much for doing this pull request, Kasia. And also, of course, the pull request before this, which was actually adding the feature, applying the pattern recognition.
Yeah, I think this is just a little sprinkle of icing on top of the big baking effort of making the feature. So
okay,
so very nice to finish it off like that. Great work.
Well, without further ado, let's move along to the demo of the week. Okay. Take it away, Kasia. Let's show us. Let me remove the overlay here so that we can see your text. Yeah, I'm really excited about this part. So please let us know all the cool things we can do.
Okay, so I'm going to show you basically the same query that we saw just before when explaining the syntax, but this time I'm going to run it live in the Trino CLI. And instead of this sample data, I'll be using real-life data. This will be the table orders from the TPCH schema. And here we have the query. I modified it in several ways. The first thing is that I had to adjust the column names so that they match the schema of this table. The next thing I changed is here. I added another sorting key, and that's just a technical detail. That's because the column order date is not unique, and I just added a unique column to the ordering keys so that we have a consistent ordering, so that on every call of this query we've got the same ordering, the same result basically. Because the match depends strongly on the ordering of rows, so I wanted just to keep it consistent. Also, I added two more measures here. One is match number and one is classifier. And they look like function calls, but they are examples of this. They are special constructs that are restricted to match recognize. And match number returns the sequential number of the match within a partition. So if we partition by customers, then match number will tell us which match of this particular customer it is. And classifier, this is a nice one because this measure returns the label which is attached to the row. So this will say if the row is a start or down or up, just as a varchar.
And I see you are also doing start, down, and up again. So you're again looking for a V pattern, right?
Yep.
Yeah, that's the same pattern. I just added some mild modifications, but I generally want to work with the query we already saw.
Got it.
All right, so I think I'm ready to run it now.
All right.
Okay, that's quite a lot. Remember that we've got one row per match. So every row of this output is a single match, a V, even without overlaps. And that's probably because we only require a small V, and this is a very big table. So just out of curiosity, I think I'll just wrap it in a count aggregation to see how many matches we've actually got on this orders table, how many Vs. Select.
Manfred, do you remember how much the tiny table has? It's like how many orders? It's like 1,500 original.
Like that. Yeah,
it's not huge, but it's also, and so
the
it's
orders table is the one that has the most. So right, like
that's the biggest. Oops, sorry. I need a semicolon, and we'll see in a moment. Right. So there's nearly 3,000 matches in this orders table. Yeah. So I think I'd like to restrict the results because I don't like to work with that load of data. So I think I'll just modify the pattern a little so that it's more restrictive. I can do it by modifying the pattern quantifiers. It says plus, which means one or more. And instead of that, I'll just put a special quantifier which says 3 or more. Or even I can say 4 or more. 3 or more down and 4 or more up. So now we are searching for a big V instead of a small one, and I hope that will reduce the output. All right, so now there's 12 matches.
Very cool.
Cool. So I think we're ready to see the matches. One row per match. So I'll just unwrap from this count aggregation. Sorry. What happened here? Oh dear.
Yeah, you can go down.
Oh yeah, thanks. I went too far up. Now the quantifiers are modified, and now I'm unwrapping this count. Okay. So these are our actual matches, right? So
nice.
If we take a look at this column match no, which is a match number, there are only ones here. And that means that for every customer, this is their first match. So there's no customer with 2 matches. They only have 1, each of them.
Cool.
But maybe we can see some more matches if we allow overlaps. And now I'm going to try it by modifying this clause here after match skip. Instead of skipping past the last row of the match, I will only skip to the next row. And from that next row, just try to find another match. In this way, we can find another V, which is hidden in the first V.
Okay.
All right, so now indeed, we found some overlaps because now there's 16 rows. Let's take a look at this guy here. This is customer 1, 2, 3, 4, and he's got match 1 and match 2. And if we look at the measures, they begin at different price, but they reach the same bottom price and the same final price, and they end at the same final date. So clearly, these are overlaps.
Yep.
This one V and another V is a suffix of that first one.
Yep.
And we've got the same situation here for the guy 400 and for 487 and here for 634.
And this would be kind of useful if you're trying to do a much more exhaustive search, like you're trying to make sure you find almost every single pattern, even if it's like you're saying there's overlap within the patterns. You want to see any time this pattern exists, even if it starts at any row, basically.
Sure, correct.
Yeah.
All right, so now I'd like to show you what happens if we output not one row per match, but all rows per match. That should be much more on the output. And I'll just modify it here, say all rows per match. Okay, all right, indeed.
Wow.
The first customer, it's his section here. It's got, how many? It's got 8 rows. And this next one here, 487, look, he's got 2 matches. Yeah.
Yeah.
And the first match is up to here.
Yeah.
Which is 9 rows long. And the second match is 8 rows long.
Very cool.
And I think that at this point, we can finally look at this last column, classy, the classifier measure.
Yeah.
And we can follow how the match exactly looks. This is the row start. These are downs. These are ups. And this is the next match with the same pattern, of course.
Wow, this is really cool because you can actually, like, you could just look at this on the first time I've seen a table, or I can actually visualize something in my head of what this like looks like on a graph or something.
Yeah. And
so can you go back to the script, like the query itself?
Sure.
So just out of curiosity, from just so to like understand for everyone. So you're going select from orders, then you go match recognize. Can you still add all the other sugar? Like this is just one clause for the select statement, right? Like can you still add where customer equals so and so?
Still you can. Technically speaking, match recognize is part of the from clause.
Okay, so you can add all the other stuff later as well afterwards. So
yes, and that could be, and from that you could select, and you could put another match recognize. You can chain them.
Okay.
Yeah, very good observation. Yeah.
So in this case, if you wanted to just look at like 2 or 3 customers, you can just literally go where customer is in blah, whatever. Yeah. Awesome.
Yeah. All right. I'd like you to take a look at this column final date. I want to explain something here. This is supposed to be the final date. That should be the last date of the match. But if we look at the column, that's not quite so. Only in the last row of the match, this is the last row of the match for the first customer, we've got the real final date. Here we've got only nulls, and then we have some different dates, and only the final one is the real final one.
Got it.
So, yeah. If we take a look at this measure declaration here, it says last up order date as final date. And this is how the engine works.
Because there is no up.
There is no up, so the engine cannot refer to it. Here in this first section of the match, there are only start and downs. So
so the trend goes down in the V, right? And then you're saying, give me the last update. Well, there is no up.
But there's no up, so it gives you null. And now in this row, the first up shows up. So he can take the engine can take the value from that row. The next up and the value is updated. And the next up and the value is updated. And only at the last one, the value is finally updated.
I'm a little confused by that, though, because wouldn't the first ones show up after the first label, up label had been made? Or am I thinking about that wrong? Or you're just getting... Oh.
Could you explain that more? I don't quite get your question.
So if you have the first row where we have up, the up label.
This row.
Yep, that row. Wouldn't the first last up be that row? The first...
Because it's last at this point. And that's actually what's called the running semantics. The running semantics is when you look only at the portion of the match that is available from the beginning up until the row that you're at.
Okay.
So in the running semantics, this is the last up because you don't see the remaining part.
Okay.
But you can change it. You can switch to the final semantics so that from every row, you can see the whole match and it will return this value for every row. And this is quite an easy modification here in the query. actually you just use the keyword final, because there's also the keyword running, which is implicit.
Mm-hmm.
But if you do final, then for every column you've got the real final date, the last date.
Cool. Okay, that makes sense.
Yeah. All right, so that's it for the demo.
Oh, great.
Wow, that's super awesome.
I mean, that's super helpful demo though. I think the thing that's hard with this stuff too is like until you actually get running something and get some at least a little sandbox demo to understand it. It's hard stuff to explain, but once you're playing with it, I think like that's the easiest way to explain it of all. And you did a fantastic job at that. So great job there. Anything else, Manfred? Did you have any other comments or things on the demo or match recognize before we move on to the question?
Yeah, no, I think that's been a great demo. It's very educational to see it in action and play with it. So I encourage everyone to maybe take those snippets and play with it themselves. And the TPCH data set is available for everyone, so that query can run as it is, and just tell us about your experience with it and how confused you are or how awesome it is. Yeah. And I'm looking forward to one of the things I'm looking forward to is, and I think that's something like you can now write this in SQL statements, but obviously this is a pretty new part of the SQL spec from what I understand, right? Yeah. So the tooling of like other tools like GUI editors and stuff supporting that is not like that mature yet. It's going to be very interesting once like, tools like dbevo or some other like reporting tools have tools to help you understand and write that query for you. At the moment, you basically have to write the SQL. And obviously that's not everyone's position, but at least you have the power at your hands now, which is super awesome. So thanks, Kasia, for doing that. It's really, really awesome. Love it. Yeah.
So far, I think in terms of like match recognize, if you Google match_recognize with the, that syntax, you'll find like most of the systems that have done this are like Microsoft SQL and like very, very industry grade SQL for servers like Oracle and things like that. So that's really where match recognize, and then like you'll scroll down a little bit and you'll eventually find the match recognize post for Trino. But not a lot of people have made this a priority and used it, but Enterprise does see this as a very useful clause, and it's something that is I think is extremely useful, as we see. Got a quick comment from Ashar again. Reminds me of the streaming analytics queries that now we can do in SQL without writing custom streaming processing jobs.
Exactly.
Maybe like KSQL DB or something like that, or one of those types of analytic queries engines. Maybe that's what he's talking about. Let us know what you're talking about.
There's a lot of that stream processing going on. There's custom stream processing engines and stuff like that. That's what Harsha is referring to. But
gotcha. Yeah, I know it was like Pinot and has some stuff like that. And also like there's like ones that you can do like window queries. It must be something like that where you're constantly analyzing based on the stream. But anyways, I'm on a tangent now. Let's go to the question of the week. All right. Again, I put it in the wrong. There we go. Now we got it up. So, question of the week. So this is actually another. I'm really liking these ones that we're finding in Stack Overflow. So I think this may end up being the more common thing that we pull questions of the week from, because and by all means, if anybody wants to submit a question still, we haven't asked about this yet, but if you have your own question for our listeners and for anybody who's watching this afterwards, send us questions, that are outside of this. We typically are looking on Stack Overflow to see things related to the show, but we're definitely into, getting questions from any of our listeners.
You can even jump in live. We might or might not know the answer, but I promise we will try to find the answer for the next episode, worst case.
Yeah, if we do one question of the week where we actually have the pre-canned answer, that we actually do the research beforehand. But then, live, we're always happy to get live questions. So anyways, getting into this, how do you tag a list of rows with custom periodic rules? And this question now, it's not the exact way the question was asked, to be honest. Somebody just put tag order ID with grace period logic, and then they go into kind of describe this grace period logic. So So I think now that we've gone through the whole background of match recognize, and Kasia did this awesome job of talking about pattern matching, I think everybody who's listening in and watching this will probably be able to fill in the details. But let's go right in and see how we could answer this question. So we have, this table here has create time, order ID, person ID, some variable, like they just called it variable A, and then they defined this is hit semantic on it. And so what they basically do is they say, okay, there's a is hit column that we basically look for the pattern of, is it equal to true? Basically, it's a hit if it's less than or equal to 0.5. So that is, for one variable A in particular is less than or equal to 0.5. So we have a couple here where we see is hit is set to true. It's 0.33 here, so it's less than 0.5. We say it's a hit. 0.4, it's a hit. 0.4, it's a hit. So we have 3 rows that are hits in this column. And what we want to do is we want to apply some grace period logic where we say anything where there's a hit, and we want to basically say that has we only want to actually do this thing called final hit, where we actually ignore hits that happen within 4 orders. So this is, basically it's ordered by the create time. And so anything that any of the next 4 rows, basically you're saying that I'm not going to consider this a hit until I have 4 more orders that come in afterwards. So they were asking all these different ways. There's really no answer to this, but the one really good answer is that we could use match recognize, of course. So I'm going to move back to my kind of extension on the answer here, where we look at the original values that were pulled in here. I pulled it in as like a CSV value. So this is the input data. Create time, order ID, person ID, and variable ID. And so we want to basically meet the is hit column first. And once we've determined is hit, we can actually then also define a grace period column. And so this was answered by Kasia internally, but on Stack Overflow was actually Martine. So they kind of together answered this, and basically what we get is we can pull this data in similar to what we did in the first earlier query. And so you guys can all go ahead and run this. You people can all run this, and basically do the same type of thing. So we do match recognize. We're going to define our pattern. So the pattern is actually going to be a grace period of 4. So we're saying every 4 rows, we want to actually make sure that we are applying this pattern matching. We don't want to do it because, again, that's the grace period logic. And Kasia, also you said this is a nice little note here. G is equal to grace period. So good commenting there. So we define that, and we were going to say a hit is actually going to be defined here. So a hit is defined as where variable A is less than or equal to 0.5, and then we then pull that pattern out. We apply the pattern of grace period of 4, and then ultimately we measure if the classifier is equal to this hit type. Am I getting all this right? I'm actually, this if syntax is actually kind of interesting to me. Could you go into a little bit more about that if syntax there, Kasia?
Well, that's just a SQL if.
Okay.
There's nothing more than that. That's nothing specific to match recognize.
Got it. Okay, yeah. Now I understand it. So it's basically just saying if this is, but what I actually don't remember.
If the classifies hit, it returns true. Otherwise, it returns null as a value, which allows you to set up those hits.
Got it. Okay, no, that makes sense now. So then, if we look back here and we look at the values, then that's exactly what came from that. So anywhere where there was not a final hit, we got a null. Of course, anywhere there's no hit, we can't get a hit. And so we look at these hits here, and we get a true value at this first hit, and then we get another true hit within the grace period, and so we don't call that a true value. It gets returned as null, just like the if statement said. And then we go after the initial grace period, and we actually get the the match here where it's going to be a final hit here. So that is the resulting logic. So really cool way that Kasia and Martin applied the match recognize application to this particular problem. Again, there's so many different examples, and I'm hopefully this kind of gets your brain jogging on, what possibilities there are to do with this syntax. It is like Kasia was mentioning, it's pretty powerful stuff. So thank you so much for implementing that, Kasia. It's really, really cool stuff.
Thanks.
Totally.
So with that, I think that's pretty much the show. Surprisingly, I think we're trying to make up for last week's show. We went way over last week.
More people back then.
That's also true. So I think we'll call that the show. Unless is there anything else, Kasia, before we left off? Any parting words, maybe about match recognize or anything that you would like to bestow on the people before we head off?
Maybe give us a glimpse on what you have in store for us next.
Yeah.
Well, we've got this feature almost complete in Trino. Until recently, we didn't have this extension to window functionality, which is now there, and it's also documented since the last version, 360. The only thing that that differs between Trino and the specification is actually the usage of aggregations inside inside Match Recognize. But I'm working on it actively. I've already got a working prototype, so hopefully we'll have that soon, and the feature will be complete.
Wow, that's great.
That's cool. Awesome. That's coming.
Awesome. Well, yeah, we'll definitely look forward to that. Thanks for your time, and we will see you all in 2 weeks. And don't miss it. All right, talk to you later, everyone.
Music for the show is from the Mega Man 6 gameplay album by Krzysztof Słowikowski. Don't forget to give us a star on the Trino repository at github.com/TrinoDB/Trino. And for more information on future shows and to find show notes, check out trino.io/broadcast.